Hello, everybody, and welcome to Apex 10 Commandments. My name is Francis Pinder, and I'm a technical architect or solutions architect based in London. And I'm here with...
I'm Kevin Porman. I'm a technical architect at Madrona Solutions Group, based in Seattle, Washington.
Cool. And we're here to give you a presentation on Apex 10 Commandments. So, I don't know why you guys are here. Maybe the name sounded cool, but I know why I'm here. And it all started on the 30th of May this year when I was having, well, a particularly bad day, I think it should be said. And I did that one thing that you should never do if you're having a bad day. And that's tweet it out on the internet. And so I said, please, if Salesforce Apex developers, remember one thing. Do not put queries in for loops. Oh, how I love fixing others' code. Yeah, it could have been a lot worse, but, you know, it was good. And then, quick as a flash, Kevin replied, I feel we, the MVPs, should create a Apex 10 Commandments document that devs are forced to read before access to the dev org is given. To be honest, I think it should be a written test with examples and everything else, but you know, they've got to learn somehow, haven't they? So, yeah. And so, you know, chatting around about that, and then suddenly April from Salesforce replied, that would be a really good, fun Dreamforce 13 session. And I'm like, yeah, we've got to do some work now.
Off to the races.
Yeah. Cool. And, you know, we kind of got thinking of, you know, what the 10 Commandments actually means. You know, what would our 10 Commandments be? And we kind of really came down to, you know, these are the 10 tenets of what you'd be thinking about when you're developing and basically not doing. For, you know, developers getting into the platform as well as developers that may have been developing for a rather long time and still make the same mistakes. And so we put our heads together and we started, you know, going through all the possible 10 commandments we could think of. I think we got to about 40 or 50, and then we thought, actually, we might have to prioritize these, and we came up with our top 10. And so, you're going to be shocked by the first 10 commandment. It is, thou shalt not put queries in for loops. So, for those, does anybody not know, I should ask it the other way around. Does anybody know what governor limits are or heard about them? Yeah? Good. Okay, fine. So when you're writing code on the platform, you basically have to adhere to the Salesforce governor limits. And these are limits that Salesforce put on the platform to make sure that customers, you know, you don't get one or two customers or that are going to monopolize all the resources of an instance. And, you know, to be honest, most of the time, you know, it's just good coding practice. You know, you should be coding in this way anyway. And so my example here, at the top, I'm basically pulling out 200 accounts from Salesforce, and then I'm just looping over those accounts, and I'm doing another query inside my for loop. And this is basically pulling back the opportunities for that account. And then I'm again looping over those opportunities to see if the probability of the opportunity is 100% and the amount is greater than 10,000. I'm just going to increment that number matching number. And then I'm just debugging out at the end how many matching records this particular account has. But when you're doing code like this, Salesforce has a limit on the number of queries you can make. So because this is in the for loop, for every single account, it's going to do a SOQL query to Salesforce and eventually hit that limit. So here we go, live demo time. Stand by. So okay, so here is my Salesforce org. So for those who don't know, if you click your name, you can dive into the developer console by clicking here. Now, what I'm going to do is I'm going to basically anonymously execute that code that you saw in the slide. So if I load up this anonymous execution window, hopefully everybody can see in a sec the same code. here we go. So we've got the list at the top, and my opportunity with the query in it, and it's going to loop over it. So if I execute this, fingers crossed, bing, bang, too many queries. So I basically made 101 queries when Salesforce limit is 100, number of queries per transaction, so per chunk of your code. So if we dive back, see here, that doesn't work. Salesforce blocks the transaction, terminates the transaction, and it fails that code. So what do you do? Well, it's obvious-ish. Pull the query out of that for loop. So here we go. So all I've done now is basically pulled that query out and put it in my query at the top as a subselect. So now the subselect is going to pull back my accounts and the related opportunities for that. And then I'm looping over those opportunities and the accounts, and then working it out in the same kind of way. So I'm looping over the accounts, and I've got another for loop there on line 11, which then loops over the opportunities within that query. Now, if I dive back into the org, I think I've still got it up. Here it is. And we'll actually just hit right. All right, now if I dive here, it's my bad code. Better code. Okay, paste that in here. So this is now the new code. So there's my subselect query up there. And now I'm looping over the accounts, looping over the opportunities. And actually here, you'll probably see if you're used to SQL, I'm not actually making a relationship between the two, because Salesforce inherently knows that this is a related object to the account, and it's going to pull back. So you don't need to make any join between the two objects within Salesforce. It just knows to pull out those opportunities. So if I execute this, ba-da, and at the bottom, we get the debug log for this. So if I double-click on here, so this is the debug for that and anonymous execution. If I hit debug only, I can see all those debug statements that are coming out for each of my accounts, the number of matching opportunities. But then if I zoom to the bottom, scroll up a little bit, hopefully. A minute. Think, yes. My log levels have changed. I think my debug. But basically, it successfully worked. I'm going to check my log levels, see if. Yeah, so but that was a successful transaction, and it worked on the platform, so woohoo! So I've pulled my query out of there. So now, for number 2, thou shalt not put DML in for loops. So DML is Salesforce's actions against the database. So you can do an insert, an update, a delete, an upsert, or a merge action against the database. And in the same way of putting queries inside a for loop, there's a certain amount of DML actions you can perform against the database as well. And I've just changed this code. And on line 4, you can see I've added a field on the account called oneOps greater than 10,000. And then inside the for loop, I'm basically setting the number matching, so the number of matching records that it's found, looping over those opportunities, to that field on the account. And then I'm updating the account in there. Now, if I execute this, it's going to do the same thing. It's going to loop over the accounts. And when it's tried to update 150 accounts, if I try and push in any more, it's just going to go, you've hit the DML limit. Now, in any development language, be it, SOQL, if you're querying the database or updating the database, a database action is a slow action to make. It's very, the server could be even, not even on the same server. So it doesn't make sense in any language, really, to put your database calls inside a for loop and just constantly pound the database, because it's going to slow your application down. So in exactly the same way we did with the SOCL and the querying, we're going to pull that DML outside of the for loop. And it's going to look something like this. So what I've done here is all I'm doing is on line 11, I've created an accounts list of accounts to update. And then I'm doing the same thing on line 23, where it's saying, setting the number matching to that account field. But then I'm adding the account to that list. And then on line 27, I'm updating the list of all those accounts that I want to update. But I've also added in, on line 22, I'm actually comparing the value that's on the account at the moment with the value I've just calculated. Because if it's the same value, I don't need to update the account. There's no point updating it. So I'm only going to update the accounts where the value has changed. And then on line 27, after the for loop has looped over everything, I'm going to update everything in one DML call. Another thing I actually see is people putting around your update, especially if you're doing this list, is if the size is greater than 0, then do the update. Well, you don't actually need to do that. Salesforce is smart enough to know that if that line 27 hasn't got any records in the list, it's not going to perform a DML call, and it won't basically penalize you one DML governor limit, I suppose. Right, now, for number 3, this is probably, do you think, the greatest sin of all? I think, getting there.
Yeah.
For me it is anyway. It's one of my greatest sins. And it's right in this code. And I'm just wondering if anybody can see what the greatest sin is for number 3. Yes, you're at the back. That's a good one. Yeah, no comments. But, to be honest, code should read without comments, So if you can read it without comments, it's well designed, and, you don't need comments. Whew. Okay. Anything else? There is another little bug, but yeah. Yes, you could. Yeah, but no, it's not that. Something even bigger than that. Nah, nothing, no, minor. Yeah, no, it's not that, it's minor. No, one more. No, not that either. Anybody else? Yeah, it's a minor thing, but yeah. You know what? Yeah. No, but that's not what I'm looking for. It's even bigger than that. Yeah. I think you're wrong anyway. I can't hear you, but yeah. Yeah, one more.
It's not as simple as the formatting of the index.
Nah, you're wrong. Okay, I'll say, you ready? You give up? Because we're going to be here all day otherwise. It is that the code is completely pointless. There is absolutely no reason why I should have written this code. This code could have been done in a roll-up summary field. So, okay, so yeah. But, this comes from an XR, button click admin, Mike Gerhold, who's got, very much, clicks, not code mentality, do it in declarative before you do it in code, which, yes, to a point is great. But I think, it needs to be a bit of a happy balance between, what you're doing in code and what you're doing in declarative functionality. But, with this, it's a roll-up summary field. I can do it in a minute, writing all that code, writing the tests for it. It doesn't make any sense. So, number 3 is thou shalt have a happy balance between clicks and code. I've seen in orgs that have gone 100% code and just trying to change things, code not written brilliantly is just a bit of a minefield. But I've also seen it go completely the other way, where everything is declarative, and they're trying to do loads of workarounds, which could have done, very quickly in a bit of code. So it really comes down to good Salesforce architectural design. So I've seen, roll-up summary fields, workflows, so field updates happening in triggers, replication of email templates, putting templates inside the code when it could have just been a template, generally, in the system. And then, the business can then change that functionality. And also, using the global settings in Salesforce to manage those, changeable variables and things within your org or static variables. So this comes on to number 4, hopefully. Thou shalt only put one trigger per object. So Salesforce allows you to put multiple triggers on an object, but there's no guarantee in what order those triggers are going to execute in. And I did have one company once where there was an update happen. It's only happened once to me, but there was an update to Salesforce, and for some reason, 2 of the triggers just flipped around. It's the first time I've actually seen it. And then the execution order is happening in a different way, and just started having some weird things happening within the org. So, generally, keep one trigger per org and use that to manage your execution of your code, which kind of follows nicely on to number 5, really, which is thou shalt not put code in triggers other than calling methods and managing execution order. So again, this keeps the trigger really clean. You can see, very clearly, these are the methods that I'm firing for my before trigger. These are the methods that I'm firing in my after trigger, and it keeps it nice and neat. And basically, and you're putting all your code in your classes outside of the methods, outside of the triggers. Okay, I think that's about it. So now I hand over to Kevin.
All right, so number 6 from across the pond here. Maybe. Here we go. Oh, there we go. This is one of my favorite tricks. It's one of the first things I ever learned about Salesforce, and it goes like this. Thou shalt utilize maps for queries whenever possible and wherever possible. At the top of this code snippet here, line 1, 2, and 3, you've got your standard list of contacts with a query of some contact information straight into a list. And if you've been doing Salesforce development for more than a couple hours, you've seen this basic thing right here. And you're just going to get a list, an array basically of your contact objects. And that's great. The problem with it becomes when you're dealing with multiple sets of queries or trying to correlate different queries together and tie data together that aren't necessarily tied together through a relationship within Salesforce. So one of the things you can do is you can query not into a list, but into a map. And that's what you'll see on lines 5, 6, and 7. It's really simple. The constructor and the construction is almost identical, but instead of a list, we're going to use a map. We're going to use an ID as the key, and we're going to use the actual object we want, so contact in this case, as our value. And we're going to construct it, but instead of just doing empty parentheses there at the end, we're going to put our query in brackets right there. And that will automatically construct a map with the key ID and the actual object as the value each time for each of our results. This is great because if you have multiple maps of data, and say one's contacts and another's accounts, and for some reason you didn't correlate that in one query, you can turn around and start pulling out, grab the account by its ID wherever you're dealing with this contact's account ID, because you've got both of those IDs at the same time. Additionally, and this is my favorite parlor trick with Salesforce, if you take and you ever are in a situation where you don't have a map, but you need one, you've got a list. Say you're refactoring code and you need that map right now. You can always create a map from a list that you've queried from just by putting that list as in the constructor of your map. Very helpful, very useful. So always try to use maps wherever you can, and even if you're refactoring and you get an opportunity to use this, you can always grab just the values by using, so in this case, contact map.values to grab the list of values if you want to iterate over the values, and likewise the keys as well, or the key set. Number 7 with the bang, thou shalt make use of relationships to reduce queries wherever possible. This one, we saw a little bit of it back on number 1. Remember how Francis took the 2 queries and he made it into 1 query with a subselect? This is the same idea, but not only can we do a subselect on a query, depending on the cardinality of the relationship, we can also use these custom relationship fields. Now, if you've been doing development for a while, you're obviously familiar with the __C fields, the custom object field, the custom fields on an object. Additionally, if you've got a relationship field, a lookup or a master detail relationship, you'll have, depending on which side of the relationship you're on, you'll have an __R field. And that's not going to show up in the UI. You just have to kind of know it exists. And you can query on that. You can traverse that relationship transparently. You can just say, give me the custom object's name field here in my query, and retrieve that back as one of your fields in your query set. You can also do your subselect. The idea is the same. You want to make 1 query, get as much of your data as you can, so you're not having to correlate maps together and do like we just talked about. But you want to grab this data and you want to pull it in with these relationships. This keeps you from having to pull all these queries. These queries are expensive. One of the things I look forward to in the Winter 14 release that kind of got rolled back was the overall time governor. If you've not heard about this, the governor is not only on query limits and DML statement limits, but also how long your code is running overall. And so the things you can do to speed up your code, things like not making multiple successive queries to grab your data, but making 1 query to get all of your data, or as much of it as you can, speed that up. So in this query here, we're going to grab the name of our custom object from contact, wherever our account matches banana pants. All right, so this is the one that might get me crucified here later this evening. Thou shalt aim for 100% test coverage. When I say that, I don't mean when you go home at night and you've only got 99% test coverage, you should feel bad about how you do your job, or when you're doing your self-review, you should say you only do an adequate job. That's not what I'm saying. When I say you should aim for 100% test coverage, I mean you want to get it as high as possible. And there are a lot of reasons for wanting really high test coverage, but the main reason you want high test coverage is it helps you know that your code is doing what you think it does. And it helps you know that when somebody comes to you with a radically different idea about what the product or your business process is supposed to look like, that you can go in there and start making edits, refactoring things, knowing that you're not breaking things that are only going to run every 6 months, or quarterly reports, or other data things that you're not going to immediately find. All right, so testing is incredibly important. And when you're writing your tests, there are 3 general things that you can write tests for. You can write tests for positive effects, you can write tests for negative effects, and I strongly encourage everyone to write user-based tests or role-based tests, however you want to phrase it. And when I talk about positive effects, I mean given the right input to your unit of code, given the right circumstances for your unit of code, this thing that you expect should happen. So if you've got a calculate method and it's doing addition, and you give it 1 and 2, you would expect 3. Your positive test case would assert that the output is 3. We're going to look at a positive test case here. This is one of the classic examples test cases from the Apex documentation. And all we're doing here is inserting some mileage records. And I don't have line numbers, I apologize, but about a third of the way down you can see we're adding test miles2.add a new mile record. We're going to add 200 of these. We're going to loop over and add 200 of these to our list. We're going to insert our list, so we're going to have 200 1-mile records. And then when we get down to our bottom of the test, down here we're going to query in the lower half, and we're going to look and make sure that the miles aren't null and that it was created today. And when we get that back, we're going to look at how many mile records we got back. And since we're running in a test class that doesn't have see all data, we should know that since we're only going to see the 200 tests test mile records we inserted. So we are going to assert that our test miles to size that we inserted of 200 should match the mileage recs that we found coming back. That indicates that's a positive test case. That's what we expect to happen. There were no validation errors. There were no DML errors. There was nothing untoward happening there. And you'll notice here at the bottom, we've got an assert equals that we've got, and the very last line here, should have inserted 200 miles and then found them but didn't. This is an optional parameter on any of the assertion methods, but it's a very powerful one. If you've ever been debugging Apex and you've got a test that's throwing an assertion error and you're trying to figure out where it is in your code, this is invaluable. I highly encourage this little bit with the descriptor of what's going on. Our negative test cases are a lot more interesting and fun to write. We're going to have to do something that forces our code to break. So when we write unit tests, we also want to think about what we know will cause our code to break. In the classic case we're going to use here is a validation rule error. So if you look about 4 lines down, you'll see that we've got a comment here. It says 0 miles will throw a validation error. And the line after it, next to the pink arrow, inserts or tries to insert to the database. Or in just a second here, it'll a record with 0 miles, and that's obviously going to fail. Now, when we make a negative test case, the thing we want to do is we want to assert the presence of a failure, of an exception. So the way we do that is we run our start test, and then we immediately open a try-catch block. And we use our try-catch block to do the thing we know is going to fail, and then our catch block, we put our assertions, and we assert that the failure we expected actually occurred. So we're going to use our try-catch block to actually catch the exception we want to see happen. So in this case, at the first blue arrow, we're making an exception, or in this case, in this test case, an exception based on a DML or a validation error. So we're going to make an assertion that says assert equals that the field miles C has a failure on the DML field record 0, which is the first parentheses, first record, field 0, which is the first field we try to insert, miles C, and that we're giving it a field, an error message, DML error should be on miles C. And then we're also asserting that the message we're expecting, the type of validation rule we're expecting, is that the field custom validation exception is the message we get back when we run get DML status code for the first record. So there's a lot to unpack in there. I'll put in the chatter for this session some links to how to find the methods on DML exceptions to break these down. But the general idea is, as soon as you try to make a negative test case, what you're going to do is you're going to expect an exception to occur, and you're going to catch that exception within your test. When you have code that deals with sharing rules or different user permissions, it's beneficial to write tests that runs as a system user and as the marketing guy or the marketing gal and the secretary down in actuarial and various people in your company that have access or don't have access or at least shouldn't have access to this data. And the way you do that is you get a hold of a user and you run the test as that user. And you'll look on line 3 here, we've got this method we're calling called system.runAs, and then I'm giving it a user. If we look on line 2, I'm creating a user. I'm actually calling a test utils class with a static method saying get a user with alias Bono. This is another one of my favorite tricks. In almost every org that I work in, I establish a test utils class, and inside that class are a number of factory methods that just return data or objects that are useful for me to test with. So in this case, I've got a method that's going to give me a user. It's going to fill in all the fields and create the user, insert it in the database, return the user to me with the alias I'm looking for, in this case Bono. And then I'm going to use that user to run this test. Now, I could be asserting in that method that it's a a marketing user only, or what have you, in order to make this test limit the permissions, etc., of the test. But I'm going to run this test as Bono. It's the standard positive test case we saw 2 slides ago. And that's all I have to do. I just have to run it as system run as. And that's automatically going to tell Apex's test runner to switch context to the user I've specified with all of their permissions, or not permissions as it were, and to run the test that way. And in doing so, I can assert that this user doesn't have permissions, or this role doesn't have permissions, etc. Very useful trick to have, and it's especially important in highly sensitive data areas. As if number 8 wasn't contentious enough, number 9 is important and near and dear to my heart. Sometimes I inherit orgs and they have unit tests, and I actually inherited an org about a year ago, and that org had 89% unit test coverage, and I thought to myself, this is great, I'm going to be able to go and immediately get to work. And I found that it had 89% unit test coverage, but none of the unit tests actually had any assertion methods in it. There were no system.assert methods in it. In fact, I did a search on all of the classes, and the string system.assert did not exist. So number 9, thou shalt write meaningful and useful tests. Salesforce requires you to write unit tests, but they're not for Salesforce. Sure, I guess in a way they are, but unit tests are for you. They're for your company, they're for your org. They're to help you sleep well at night so that somebody's not calling you and saying, why is this process broken? Write meaningful tests. Salesforce gives you 3 assertion methods. The first one, the system.assert method, you say A is equal to B. If that returns true, you're good. If it returns false, you're going to get an assertion exception. Assert equals, same idea. You know, if A and B are equal, then we're good. And assert not equal, if A and B are equal, then we're not good. But when you are writing these unit tests, do meaningful things with your unit tests. You want to test with your own data. Salesforce gives you the option to run this annotation called see all data, but it's a Faustian bargain at best. It's a double-edged sword. Write your own data, populate the database, and populate the test for your tests before you run them. If we look at this code here, we're going to run this test utils class again. We're going to grab an account. We're going to modify the last name, and then we're going to start the test. What this does is this lets us set up some data ahead of time for our test. Then we're going to start the test, and that resets the DML limits and all sorts of other goodness, so that when our test code, the code we're testing runs, it runs as if it were running in production. And then we're going to run a class here, creatively named ensure last name not null. It's a static method. So with A, if I'd put A in parentheses there, it should throw an exception because A.last name is null. And I'm then going to assert after my stop test is run that my last name is not null, because that's what the method implies it does. The idea here is create your own data, run with your own data. So create a set of data, put that set of data in your test utils method, and be able to call on that to not only get an account for your testing, but an account without a last name, or to be able to quickly just nullify the last name in order to write your test. This is the hard one. Meaningful unit tests do one thing, and they do that one thing, and then they go on to the next thing. So your unit tests need to maintain focus, and they need to just test one thing. Sometimes we write unit tests that will test an entire method, and that method is 800 lines long. And there's probably other issues with that. But when we're testing a unit test, when we're writing a unit test, we're not writing a method test, we're writing a unit test, and we're testing a unit of code. And that unit of code may be smaller than the method we're testing. We're maybe testing whether or not it correctly goes into the branch of execution, the if statement we're looking for. So we need to do one thing at a time. Oops. And when we run that test, those tests that maintain the focus and they do test one thing at a time, they're going to run much faster. Now that means you'll often end up with 20 unit tests for the same method, especially if you have an 800-line method. But the benefits there are great in that if you end up changing the execution path, an if statement, for instance, you immediately know what else that's impacted. And number 10 with a bang. Thou shalt limit future calls and use asynchronous code where possible. This is a little bit of a misnomer, I admit. Salesforce refers to @future annotated methods and batch apex and scheduled apex all as asynchronous code. What I'm specifically referring to here, however, is the idea of using batch apex rather than @future annotated methods. And there are some trade-offs, and the idea here, though, is that with your @future annotated methods, there's a limit to the number of them that you can queue up at any given time. And you can rapidly get yourself in trouble. So here the idea is we just want to bias towards batch apex. Write a batch apex class, you're going to get better test coverage out of it anyway. It's going to be easier to test, and you can enqueue a batch test, you can schedule a batch test, a batch apex class, etc. And you can also ignore that and run your @future when you need it. But the idea is use batch apex wherever you can. It gives you more headroom and more runway for bigger projects down the road. When you're doing either one of these, you need to tune what you're working with. Even though there are relaxed governor limits for asynchronous apex for batch and @future methods, you still need to tune your callouts. If you're going to call out to an external third-party web service, or you're going to be making a SOAP call, etc., tune those for timeouts. You need to, when you're making SOQL queries from within them, make sure you're using the relationship queries we talked about. Generally, keep those as tight as possible. And then that works for either one of them. So when you're dealing with your batch apex, you want to tighten it up as best you can. And when you have to use the @future, tighten that up as well. And I think at that, we've got a few minutes here for Q&A.
I think, yeah. And also, make sure that you write the survey and say how brilliant or terrible we were so we can come back next year. But other than that, yeah.
Question.
Yeah, there's 2 mics if you can line up at the mics if you want questions, yeah.
Question about test methods. You say test one thing and one thing only. When you're writing, you said you might end up with a lot of unit tests. Would that refer to multiple test methods within one test class, or are you referring to multiple test classes? And if you're doing it all in one test class, you can set it all up at once and then reuse that setup, or does it make more sense to set it up new each time for each test?
So I like to do multiple unit tests within the same test class. I almost never reuse test data between test runs, individual test methods. I find it's more headache and head scratching than anything else. So I just set up the data and use it as I need it. But the great thing about it is the data you use in a test gets rolled back and thrown away anyway, so why not set it up as you create the test? So I would say multiple test methods within the same test class. I tend to write one test class per class that I'm testing.
Okay. Aside? Yeah.
A little similar question, I guess, about test data. You talk about creating your own test data to use in your unit tests. How does that help you test when data conditions may cause unexpected errors, for instance? Isn't that a little non-defensive, I guess?
Yeah, that's a great question. I don't want to, if you've got things, feel free to jump in here too.
Sure.
So in general, every time I run into a fun data anomaly that causes something to go wonky that I haven't tested against, it immediately gets added to my test data. This is especially true now that I think it was 2 releases ago, you can now create a static resource, CSV, of test data and reference that in your tests. It makes it really simple to just, open up a Google Doc, add that to my test data, and put it back in. This is great when you end up with, I just read on Stack Exchange, there's actually a company who employs a man whose last name is Null. So situations like that, or
XKCD, right?
yeah, little Johnny Tables, or not to pick on the Irish, but O'Malley, the apostrophed names, that sort of thing. Those all go into my test classes, and I tend to reuse a bank of test data. Perhaps I should publish that.
Yeah.
Okay, another question about test data here.
I'm sensing a theme.
Okay, so here's the situation. I am doing something in batch Apex, okay? What it's doing, it's setting a few fields which are dependent on the actual amount of data in there. So when I run the test version of this batch Apex class, I want to make sure it only counts my test data and doesn't count the data that's already in the org. Okay. What's the best way to do this? Is the best way to create a flag in the batch Apex called debug only or test only and use it that way?
So if you, I forget what the API version is, but if your test class is written and set with an API version of, I want to say it's 27.
24?
24?
Yeah. Okay.
24 or newer, and you don't have your test set to see all data, your test should only see the data you insert before you run it.
Okay.
So the idea here is you're going to, insert a whole bunch of data for your batch Apex class to consume, insert that, then run test.start test, run your batch Apex test, test.stop test, run your assertion.
Okay, and it
And
will only see the data that you added.
Yes.
Okay, I didn't know.
And you can upgrade the class, so if you do want to do that,
Yeah.
you can go into the interface and change the version of the API it's going to run against up to 27 or 25, the one above or higher.
All right, thank you.
Hi, thank you for the presentation. I have a question about the negative unit test that you had a few moments ago. And I'm brand new to Apex, so I'm not 100% sure about some of the syntax things. One of the things I noticed, though, is that you had a catch clause, but you didn't have a finally clause to say that the exception was actually thrown. Is that something that's not supported for error handling, or is this, or was I blind, or is that somehow handled with the test?
So the good news is you're not blind. There was not one there. That's a great question. I don't think they're supported. I don't ever use them in Apex.
Yeah, it does.
It does?
Yeah,
Okay.
it does, yeah.
Bad on me. I should probably use them.
For number 3, the balance between code and clicks, I agree with that in theory, but the example you gave is actually one of the things that I took the opposite position when I had an opportunity to write coding standards for our company, in that you should never use master detail relationships or roll-up summary fields for 2 reasons. One is updating the child has a habit of kicking the user out of editing the master record. With the user, another user has updated the record. And second is the way triggers work with deletes. It doesn't call it on the child records, which kind of limits your flexibility in a number of different ways.
Yeah, absolutely. And actually, a lot of orgs, I use the roll-up summary helper application, and actually that does exactly that. But it's still declarative. It's still, you can create these fields, and so you don't have to do any in code. But yeah, and then that kind of gets around that issue. Yeah.
If I can suggest,
another commandment, thou shalt comment thy code as if the person inheriting your code is a psychopath that has your address.
Yeah, probably very true. Yeah, we came up with, there was a lot of other commandments that didn't quite make it, but yeah.
I'm sure you have great questions. Unfortunately, we've got
2 seconds and we're out.
So I'll be right outside if you want to ask your questions.
Thanks very much.